just like actual class. Cool. Okay. The opener, what you should have learned last week was this thing called multiplying rational expressions, which is this thing right here. Well, if you follow the lesson, we're following this thing called FCM, which we all know stands for do we have work over spring break? No. In this order, specifically in this order, do not do any canceling until the first step is done. I will still see students attempting to do this, something that kind of crazy. We're not going to do that. Why aren't you doing? Oh, there we go. Cool. Ah! Oh, crap. Okay, I got to write that down again. Factor, cancel, multiply. Okay. Cool. I'm going to factor every numerator and denominator I can do. So if you did this opener, the top over here factors nicely. This factors nicely. Multiplied by x minus 2. Nothing to factor there. No common terms whatsoever. Do you guys see the dot that's going around? Just nod your heads. My cursor. Thank you, Jade. X plus 4. Nothing else to factor, so now I will cancel. What cancels? Oh, these. If it were a parenthetical, then would it be okay? Like parenthesis? What? Yes, just those. Parentheses, yes. I mean, no, still no. If this was a parentheses, but it also has to be the same exact thing as well. Meaning, again, this is the handcuff that's tying them together, which we will not cancel it unless this also has a minus 2. Whoa, okay. Just the x plus 3s. And then we're just going to mash everything else together. Like so. You can just leave your answer like this. I know the last step says multiply it out, but honestly, you don't need to. You are technically still multiplying them by smashing them together like so. But we don't want you to multiply it out. You could if you wanted to, but this is a fine answer. Okay. Adding fractions. Oh my goodness gracious. Collectively, hopefully, you all will say, if this was an actual classroom and I wrote this, everyone should go, no. And I would be like, well, when you do this, you multiply it across, right? You get 54 over 49. So I just subtracted across. And then everybody's like, no, that's not what we were taught in a long time ago. No. Why? I want to undo all this. Undo. Oh no, the undo button is... Oh, I'm pressing the wrong button. Okay. Of course, that was not what you were taught. The real answer, of course, being easily 3 over 7, because we are now subtracting or adding. Same denom. Don't change me. Okay. Uh-oh. Naturally, if I wrote 3 over 14, you'd be like, no, Mr. Viernes, don't be like that. Don't be like that to me. Now, you, of course, hopefully should remember that we want the same denominators. But let's really talk about how and the process of what it means to be a common denominator. Naturally, you might have all said 45. And this is how I do it. I write both fractions again, but this time knowing what the new denominator is going to be. Now, let's understand first, how do you know it's 45? There are a couple of reasons here. One reason being least common multiple, the smallest number. Yes, that's true. The smallest number that they both multiply up to is 45. Also, as Lucas said, just 9 times 5 gives me 45. Okay. And then naturally, how do we know what ends up going here? Well, to get to 45, this needs to be multiplied by 5, which means I have to also multiply the top by 5, and we get 5 here. And basically, that's equivalent. 1 over 9 is basically the same thing as 5 over 45, which you hate. Yes, I do. And then you have a giant one here, which I'm going to do 9 over 9, which becomes 18 over 45. My answer is 23 over 45. And if we could reduce down this fraction, we will, but we can't. Now, if we look at this, again, this is the new fractions. There stands a question on what would be these two. There's a couple of decisions here. You could, of course, go 12 times 8, which gives me 96. If you really wanted to, you could put 96 here and 96 here. However, that is not the least common multiple. The least common multiple of 12 and 8. In other words, the smallest number that they both can multiply up to. There's a couple ways to do this. One way to think about it is think about it. If this was a classroom, that would be a riot joke. Like everyone be like, ha ha, okay. We could just think about it. The more unknowing way is to just we're gonna just draw out the factors and see what's the smallest ones that they have in common. This has a wait a minute. No, that's not how you do it. Is take 12 and keep multiplying it by something, maybe times 2, you get 24. Wait a minute. 8 goes to 16 and then 24. Oh shoot. I'm going to make them both 24 instead. $24 and $24. Which means I need to giant one a 2 here over 2 and a 3 here over 3 to get 30 here and 10 here. My answer is negative 20 over 24. Negative 10. Wait. Negative 5/6. Okay. Mr. Viernes, why are you teaching me fractions? Well, I'm so glad you asked. How well is this going to work? It's not going to work well. I'm just going to write it. Okay. So now we get, wait, why, what? Uh-oh, okay. So now we get into the actual lesson. How do we add this? We've actually done stuff like this before. But what I'm more interested in is the concept of what would be the least common multiple here. What is the LCM here? And some of you guys might actually guess pretty easily. 5x, that's a good answer. And is the it is, of course, 5x. Now, you may not be as instinctual as Hazel. Instinctual. Is that a word? Can I Google that right now? No, I'm not going to. Okay. Why is it 5x? Hazel, I'm unmuting you. How do you know it's 5x? How do you know it's 5x?
It's 5x because you can use a giant 1 on the first fraction, and because the denominator is equivalent to 1 because it's 1x. So then the second fraction can stay the same, and you can make the first fraction 5 over 5x.
Okay. I'll take it. Thank you. Essentially, I could turn this first fraction, as Hazel said, into that fraction by using a giant 5 over 5. That's one way to explain why 5x is the LCM. There's another way to explain it. Oh, wait, first of all, I don't need to multiply, or second of all, I don't need to multiply the second fraction. This could stay as a 3. This turns into 5 over 5x. Now, we're not going to finish the problem yet. I don't want to finish the problem yet. I'm more trying to understand why this is. Another reason why this is. We can also follow the same reason we did up there for 45 up here, where my mouse is. I just took 9 times 5. We got 45. However, if you do 5x times x, you would get 5x squared, which is not the LCM. Not the LCM. Okay, here is my really dumb analogy of how to explain the LCM. Think of a kid in a candy store. And he wants one of each candy. So he goes to the store and he goes, ooh, I want an X. I want a 5. I could get this X, but I already have one. Hence 5X. Okay, that explanation is going to make more sense in the eventual example. However, for now, let's accept the answer as just 8 over 5X. I'm going to put a box around this, though. See, as the denominators stay the same, 5x, 5x, don't write it to 10x. 5 plus 3 is just 8 over 5x. Let's make it more difficult. What is the LCM now? Again, we're going to change the denominators because they're not the same. Now, you might think, whoa, this has a +1. Can I just add 1 here? Not necessarily. We can only change. Whoa. We can only change. Stop. Okay, we can. Why are you doing that? Stop doing that. Okay. Whoa, stop. Okay. Why are... We can only change fractions by multiplying here. The question is, what is the LCM? Just like a kid in a candy store, he goes to the store and goes to each denominator, which is a bin. Oh, we have a question or an answer. Wait, no, not you. Where'd you go? There you are. Yeah, unmute. Dahlia.
I have a possible answer.
She's talking in slow-mo.
X squared plus X. Oh.
Say it again. I heard X squared plus X.
Is my microphone working?
You're correct. Thank you. Now, okay. I don't like this is correct, but I don't like the way she wrote it. Let me go back to the kid in the candy store thing. So the kid goes to the store and he goes, "Ooh, an X plus 1." And he goes, "Ooh, also an X." And now there's nothing left. My least common denominator is X parentheses X plus 1. I know it's the same as this, but I want to write it like this, and here's why. Now I know my least common denominator, which my two common denominators will now be both this. By writing it like this, I could now see exactly what do I need to multiply by each one. Let's use green. What do I need to multiply by? What giant one would change this to this? What giant one would be? This is X plus 1. This is X. What is the giant one? Not 1 over 1. X over X. Because this times this would give us this. So which means on top here, I get X squared. We almost don't care what happens on top. What the hell? Why does someone have a picture of Mr. Rusich as their... Is that Mr. Rusich? That is Mr. Rusich. It's not actually Mr. Rusich though, right? Okay. Oh, Aiden. I think that's the same. Aiden G? It is Aiden G. Okay. All right. The giant one here, this is X plus 1. X plus 1 over X plus 1. That's what this needs to multiply this times this to get this, which means on the top here, you have 3 times this whole thing. So this is 3x plus 1. That's essentially the most difficult part of doing this, is making sure that your, of course, denominators are the same and getting the correct LCM. Now, once we have both the same denominator, just like what we did up there, our final answer will have this. But the question is, what is on top here? And I look here, this says x squared plus this plus this. Well, none of these are like terms, but I could certainly write them adding to each other. What we want to do is distribute this and then add this all together if there are any like terms. But as one single fraction, we get x squared plus 3x plus 3 all over x parentheses x plus 1. Honestly, don't... Oh my goodness, I hate this. Okay. Oh boy. Stop. Oh, did I just draw? Okay. Stop here. This is going to take a lot of practice, more so than last week's lesson. Because I would say it gets pretty hectic at the first step, but finishing the problem is still a little crazy. So let us do another one. Wait, were we cool? Is it cool that I got rid of that? No one's complaining. Go back. No. Yes. No. Okie dokie. Okay. Insert blank page. Okay. I'll give you guys something similar to do here. I'll put a 2 here. I like to identify the LCM, which is, of course, I mean, I really could call it at least LCD for liquid crystal display. No. At least common denominator. But LCM is fine. We're thinking of the kid in the candy store. He wants an X. He wants an X minus 2. He wants an X and an X minus 2. From then on, try to finish the problem. What would be the giant one on the left? What would be the giant one on the right? Okay. Did you write X? Oh, whoa, whoa. Why? Stop. Okay. Did you write X? Did you write X over X here? And X minus 2 over X minus 2 over here? If so, that's correct. X over here. And this becomes, be very careful. It's X minus 2 times 2, which you get. I hope you wrote 2X minus 4. You didn't get fooled? Okay, cool. Okay. The bottom now of our final answer is going to be X parentheses X minus 2. The top, someone type the answer of the top. I should cue the 3X minus 4. Oh, yes. 2X plus X gives me 3X. The negative 4 does not combine with nothing. And this is my final answer. But Mr. Viernes, I can't help it. I want to cancel these. No, can't stop here. We're adding and subtracting now. This is an entirely different beast. As in, we're not doing any FCMs here. We're doing LCMs here. Okay. So, if you really need some steps, that's probably the most important step. Giant ones. What are they? Then Find the LCM. Giant ones, obviously, these are the both two crucial steps of this. And then add and subtract into one fraction. Again, we're kind of going really kind of big baby steps here, but they're baby steps because I'm about to open the floodgates here. Any questions up to this point? Dang, people left. Okay, they're like, this is just adding fractions. This is easy. I'm like, all right, here we go. I don't like that. Let's use this. There you go. I'm scared. Yeah, I know. Me too. Will the real victim maximum? Okay. Oh my goodness. Zounds. The word I just said was zounds. Zounds. 1 over x squared minus x minus 12 plus 1 over x plus 4. That is quite the dooze. The biggest step, of course. What the heck is my LCM? Now, just like what we've been doing last week, it's sometimes easier to see this if we try to factor what we could factor first. I could add an extra step, but I don't really think it's necessary because it's all lumped into number one, finding the LCM. And in order to find the LCM here, it might be helpful to factor. Factor what, you ask? Well, the thing that I can identifiably see is what can be factored. This is x. Oh, crap. I just screwed myself. Okay. Let's pretend for a moment that's a plus x. There we go. X squared plus x minus 12. I'm so sorry. Okay. What we get here is x minus 3x plus 4. 1 plus x plus 4. As we can see, we could now see what the LCM is. The kid walks into the store and goes, ooh, I want an x minus 3. I want an x plus 4. And he goes to the second person, to the second fraction, goes, I already have an x plus 4, sucker. So my LCM is just x minus 3 parentheses x plus 4. So I have now identified my LCM. I will now use my giant ones. This is my new LCM. And I go, whoa, wait a minute. First one does not need to change. Why did you only LCM one side? Oh, I see now. The other side, I need to multiply this by the giant one of, this is x plus 4. This is x minus 3, x plus 4. My new giant one is x minus 3, x minus 3. So this new denominator becomes x minus 3. So again, we've dealt with finding the LCM, which required factoring. Then we've dealt with what the giant one was. There was only one we had to do, which was x minus 3 over x minus 3. The final answer taking us over to x. 1 plus negative 3 is negative 2. The x has nothing to combine with, and here is my final answer. Stop. We got a hand. Dahlia.
Why is it x minus 2? The one before it is x minus 3. Why is the final answer x minus 2 when, oh, wait,
You're
no, that,
can you try typing your answer? You're hugely breaking up.
sorry, I was multiplying instead of subtracting or adding.
Okay. Okay. Just to type it in though, like, are we good? Not good. We're good. Not good. Never mind. Figured it out. Cool. Okay. Any questions? Any other questions? By the way, this is the glove for the writing stylus. It's not because I think I should be wearing a glove. Any other questions? Okay. Let's make this more difficult. Actually, yeah, this is pretty difficult. Okay. Whoa. No. There we go. Oh, let's do purple. Wait, what? Effects? These have effects too? Oh, weird. Okay. I kind of like this marker. X plus 1 all over x squared plus 6x plus 9 minus x minus 3 all over x squared minus 9. I'm waiting for someone to provide to me what they think the LCM is. What's going to be the new denominator for each of these? This is a little tricky. Actually, this is a little, I'm gonna just do it. So this is x plus 3, x plus 3. Okay. This is x minus 3, x plus 3. Okay. I just saw this, and you might be naturally looking at something right now, and you so want to do it. So here is first mistake number 1 people will do, and I've seen this 2 times over, and I get it. Why? What some students do is when they're done factoring, they've learned to, oh, ha. But no, we don't want to do that. This is adding and subtracting. In fact, don't cancel here. It is not listed in my steps. Do not cancel, because we're not multiplying and dividing. Very rarely canceling like this is going to help us in this type of operation for adding and subtracting. So don't do that. Follow the steps. What is the LCM? So the kid walks into the candy store and he notices there's an x plus 3 here. So and then we want an x plus 3. There's another x plus 3. Now, I know I said that he only wants one of each, but technically this denominator is in the same bin and it counts as a double. So he would now want 2 of them because this single denominator has two of them, I want two of them also. He would then go to the next door and goes, hey, there's an x minus 3 here. So I want one of those too. But he's already got two x plus 3s that he got from the first denominator, which counts as a double piece of candy, so to speak. I really hate that's the only analogous explanation I can have. So this must be my LCM. X plus 3 squared, because it's in the same denominator. It has to be it has to be written down twice like this. So here is my new denominator. Now, this is not one of those make or break problems for a test or a quiz. If this was a test or a quiz, they're not all going to be this particularly difficult. This is a type of question that would separate A's from B's, but not necessarily from passing or failing. It is a difficult concept to understand why it's x plus 3 squared. That's the best way I can explain it, because it's coming from the same denominator. We want both of them like that. So we now know our LCMs. We are now going to figure out our giant ones. Could you try to type it, and if you start being robotic again, or you're good, Dahlia? Okay.
I switched Wi-Fi. I think I hope is this okay? Is my audio okay?
It's a little better now.
Okay. So, if we took the x plus 3 squared, we took both of them because they're from the same denominator. Why didn't we take both of the x minus 3 times x plus 3 since they're both the same denominator too?
Because we already have an x plus 3 from the other denominator. It wouldn't be the least common multiple in that case.
Okay. So to clarify, the reason why we took both is because they're the same like grouping of numbers in the same denominator.
Yep.
Okay.
This is going to be, it's x minus 3, x plus 3, but we want x plus 3 squared, x minus 3. So what is my giant one here? I want to go from here to here. Should be x plus 3 over x plus 3. This will now change to this. And the top here, oh boy, multiplying this to this, we get x squared minus 9. Over here, I have my giant one is x minus 3 over x minus 3. That's what will change it there, giving me, I'm just multiplying this out. I apologize that I'm doing it in my head, but I do get x squared minus 2x minus 3. Whew, those are the first two steps. Again, as I did say, yes, is the squared part of it the double candy? It's kind of like you go to a bin and then there's a Twix bar, which the Twix bar has, oh God, my analogies are, Twix bar has two things in it, so he's going to take the whole Twix bar, and he goes to the next thing, and it has a Twix bar with one single, I'm done with the analogies. I'm so sorry. I live kind of close to Ranch 99, and there's that candy store in there. I should just walk in there and get candy if it's open. Do you think it'd be open? The candy store? Why is the giant one x plus 3 over x plus 3 and not x plus 3 squared, x plus 3 squared? Because, wait, over here? because it just needs one other one to get to x plus 3 squared. X plus 3 times x plus 3 is x plus 3 squared. So it just needs x plus 3 only to change into x plus 3 squared. Thanks, Gabe. That answer your question, Dahlia, before I finish the problem? What I said was, again, okay. So this minus this. Notice, again, we're not touching at all the bottom at all. Because, like in adding fractions, this is just going to stay the same. On the top here, we do get x squared. Well, combine like terms. X squared minus x squared, that's gone. Negative 2x minus nothing is negative 2x. Negative 3 minus 9. Type the answer. Negative 3 minus 9. Negative 3 minus 9. Yikes. No! Negative 3 minus 9. Thank you. Okay. You could stop here, but technically you can take this further. But before I show you how it takes it, how I can take it a little further, even though I wrote the word stop, because honestly, I would just look for this. Are there any questions? Deep breath. Yes. Thanks. Are there any questions up to this point? I would say this is the most difficult it could get when it comes to adding and subtracting. Anything else in the handout classwork should be fine. Okay. So we can actually take this a little further. The top here, we can apply Grandpa's rule, which states that if they have a common term, I'm going to factor it out. I'm going to factor it out negative 2, which gives me x minus 3 over x plus 3 squared. And only now can I actually cancel. And you should see that's x minus 3, x minus 3. So my real final answer is x plus 3, 2 over x plus 3 squared. But both of these, I'm just showing you we could take it further, but it's not necessary. Again, that's why I'm saying stop. I would accept this when it comes to adding and subtracting. In like a 3+ class, it would be probably marked 1. Negative 2. Oh, thanks. Okay, that's pretty much the end of the lesson. That should be enough for you guys to tackle the classwork, which I will now post, which I'm technically supposed to post tomorrow, but I might as well post it now since you guys are here and you could start on it. I can stick around for any questions if you want to start working on it now and you want to